Alright, this next part we're going to solve logarithmic equations, and it says be sure to reject any value that's not in the domain of the original logarithm of the logarithmic expression. Now remember we said for our domain for logarithms that the argument must be greater than 0. So we want to make sure that basically that means that the argument is positive when we plug our solutions in. So let's keep this in mind as we solve. It wants us to give an exact answer. This first one is easy to solve just by rewriting this from logarithmic to exponential form. If you recall, our first lesson on that is this raised to this equals this. So we get 3 to the 4th power is equal to x. That's just simply using our rules to change from logarithmic to exponential. And in this case, 3 to the 4th power is going to be 81. And we solve that. Now number 9, we're going to use that same rule, rewriting the exponential. So it's 4 raised to the 1st power equals this argument. Okay, so let me write that. So that's just going to be 4 to the 1st power, which is just 4, is equal to that argument. And remind me in just a minute, we need to go back up in 8 and make sure that our argument, the answer is 81. If I put 81 in place of x, I need to make sure that that's positive. So this one does check in the domain. We forgot to check this. Okay, so now we're just solving. Back down here, we're solving for x. So 4 is equal to x minus 3. We want to get x by itself. Add 3 to both sides. So we get an exact answer, 7. Now let's go back into the argument and check. So if I take this 7 and put it in for x, what's 7 minus 3? 4. Is 4 a positive value? Yes, so this is a valid answer. Okay, number 10. What I want you to look at is see, oh, this has 2 different logarithms on the left and none on the right. I can't really rewrite a logarithm as an exponential, in a logarithmic form to exponential form like I've done previously, unless it has one logarithm on this side and a value on this side so that it matches our format. So is there anything I can do with these two possibly to rewrite it as 1? We can condense using our properties because this is the same base, log base 4, log base 4, and since it's addition, we can rewrite these as the multiplication. So I keep the same log base, and this can be rewritten as x plus 3 times x minus 3 is equal to 2. Now this matches our format, and we can rewrite this in exponential to solve. It's just a lot more complicated, the argument, but that doesn't change anything. We still have this raised to this, so I'm going to say 4 squared. So this raised to this equals this whole entire piece. So we get x plus 3, x minus 3. And then we just want to do the algebra with this. What happens when you have x plus 3 and x minus 3? The middle terms cancel, so yeah, so we would just get 16 is equal to x squared minus 9. Boil it all the way out if that makes you more comfortable. And then let's solve for x squared. So we get 25 is equal to x squared. How do we undo a square? Square root of both sides, but don't forget when you take the square root you get plus or minus 5. So we want to look at x is equal to 5, and we also want to look at x is equal to negative 5 when we check it. Okay, now let's check x equals 5. Go back to the original equation, so let me move this out of the way so we can see. And let's plug in a 5 right here. What's 5 plus 3? 8, so it's positive, check. What about 5 minus 3? 2, that's a positive argument, check. So this one is in fact okay, it checks out. Now let's check this solution, negative 5. What happens if you put negative 5 plus 3? You get a negative argument value right there. This one does not get to be included as a solution. All right, what's the known base for this one? It's not shown, but it's e. So basically, move that out the way. So you get this raised to this equals this. That's our exponential form. So we just get that's b to the y equals x. So this is just e to the third power is equal to x, which you simply put that in the calculator. You can either give this as the exact answer or you can put it in the calculator and get an approximate answer. Alright, so one log over here, we can take it from logarithmic form to exponential form and just say this raised to this equals this argument. So we would get 9 to the first power, which is just 9, is equal to x squared minus 8x. Moving it all to one side and getting this set equal to 0 is to subtract 9 from both sides, and we just get this value when we move 9 over to the right. Now we can use factoring to factor this, however you want to do it, whatever method you use. What multiplies to give us negative 9 adds to give us negative 8. It's going to be the factors are x minus 9, x plus 1. Okay, using bottoms up, we're looking for the factors that multiply to give you negative 9, add to give you negative 8. So I can check these. Negative 9 times 1 is negative 9, but negative 9 plus 1 is negative 8. So they check out. And then when you set x minus 9 equal to 0, you're going to get x is equal to positive 9. Okay, and then when you get x plus 1 is equal to 0, set this one equal to 0 and this one equal to 0. That's what we're doing over here. You get x is equal to negative 1. Now let's check these. Let's put a 9. What's 9 squared? 81 minus 8 times 9 is 72. So 81 minus 72, do we get a positive number? Yes. Alright. What about negative 1 squared? A negative 1 times a negative 1 is just positive 1. And then negative 8 times a negative 1 is positive. So will we get positive? Yes. So both of these solutions are valid. Alright, number 13, we see log base 10, log base 10, log base 10. So that makes me feel comfortable. They're all the same base. That means I have properties that I can use. But I'd like to have just one on each side because we have a one-to-one property. If I have a logarithm on one side and a logarithm of the same base on the other side, we have some properties, a one-to-one property we can use. Is there any way I can rewrite these two and condense them to be just one? Yes, using our properties from earlier, because it's addition, we can rewrite them as multiplication. So we would take argument 5 and multiply it by x minus 2. The known base is 10. On the left side, I'm just going to carry this down. Now I have a log base 10 is equal to a log base 10. This allows one-to-one property, and we just set the arguments equal to one another and solve. So 3x is equal to 5x minus 2. And we'll solve this out. Okay, so unpause it and check your steps on your algebra. Test the 5, and 5 checks out. This is our solution. So let's look at the last one, number 14. Okay, log base 10, log base 10. There's only one log on this, one log on this side. So we use our one-to-one property and just set arguments equal. So x plus 4 equals arguments equal one another. 5x minus 5. And solve this for x. Okay, check your work on the algebra. We get x equals 9/4, and we check it in here, and it's a positive argument, so it satisfies. Okay, this is an extra example that some of you may see in your homework, and so I'll just let you pause it and look through this. But one of the things you want to pay attention to is that they give you the y value, which is the intensity, is 1%. So most people make the mistake and plug that in for x, and that's not right. So you'll put that 1 and then you use natural logs to solve this.